right, Math 9, I hope you've been working on your assignments. What I wanted to do was do just a quick review video on some of the stuff out of chapter 5 because it's been a while since you've looked at that. And it's really probably one of the most important chapters in the book in terms of you're going to use it again in high school. So I want to go over just some of that. So the first thing they ask about is common factors and greatest common factors. And there's where we sort of talked about tree diagrams a little bit. If I gave you, I don't know, 248 and 684, and I said, what is the greatest common factor between the two of them? Well, you can guess if you want to. I wouldn't recommend it because maybe I'm going to guess that it's 4 because 8 is divisible by 4 and 4 is divisible by 4. But it could be way bigger than that. The greatest common factor, the biggest number that will divide into both 248 and 684. So we talked about doing a tree diagram, breaking them down into their prime numbers and seeing what is common between the two of them. So for 248, I would actually just keep dividing by 2. So 2 times 124, and 2 is a prime number. So that branch stops. So then I would divide 124 by 2, and I get 62. So that's a prime number, so that branch stops. Then I would divide 62 by 2, and I get 31, which is a prime number as well. So really 248 is 2 times 2 times 2 times 31. And you can check that. You can go to your calculator and go 2 times 2 is 4, 4 times 2 is 8, and 8 times 31 is 248. Like, it works. So 684, I would use the same process. 2 times what makes 684? That's 342. So that's a prime number. I'm going to divide that one by 2. Whoops. Sorry. 342 divided by 2. So 2 times 171. Now 171 is not divisible by 2, so is it divisible by 3? Yes, it is. 3 times 57. That is a prime number. The question is 57? And no, it's not. It's actually 3 times 19. So 3 is a prime number, 19 is a prime number. So it's actually 2 times 2 times 3 times 3 times 19. And again, you can check that. You can go to your calculator and multiply 2 times 2 times 3 times 3 times 19, and you should get 684 if you did that right. So now I need to see what is common to both. Well, this one has a 2, so does this one. This one has a second 2, so does this one. This one has a third 2, but this one does not. The only other thing this one has is a 31. This one does not. So 2 2's are common to both, and 2 times 2 is 4. So that is the greatest common factor. Now remember, I said you could guess 4, and you might be right, but you can't be sure unless you've actually checked it. All right, and again, you really should be showing me your work. If you guessed 8 and that was wrong, and say this was worth 4 points, and all you put was 8 as your answer, all 4 points are gone, right? But if you did the tree and you just by accident wrote a third 2 there, but this was all right and this was all right, only 1 point is gone. That's a significant difference. 4 points versus only 1 point. Show your work. So then we talked about factoring just an expression. So if you have 4x squared minus 8, there are common things. There is a number that I can divide both this and this piece by. there is a common factor. The common factor is 4. If I divide this by 4, what I have left is x squared. If I divide this by 4, what I have left is 2. The 4 needs to be out front because the word factoring just means you're breaking apart this expression into its pieces. So what a lot of people do is they just put x squared minus 2 and they don't bother to put the 4. But there's no way I can take x squared minus 2 and get an answer of 4x squared minus 8. But 4 times x squared minus 2, well, 4 times x squared is 4x squared, and 4 times negative 2 is negative 8. So I can come up with the answer. So factoring means break it apart into its pieces. All right, if you have a puzzle all put together and you factor it, you just take it apart and put it into all its pieces. So piece 1 is 4. The other piece is x squared minus 2. So factoring just means break it apart into its pieces. One thing that people don't do, if it was 4x squared minus 2x, the common factor to this is actually 2x, because I can divide this by 2x and I get 2x. And I can divide this by 2x. A lot of people put nothing here because they're like, I put the 2x out here, so there's nothing left. But that's not true. If you have 2x over 2x, that's actually 1. 2x anything divided by itself is 1. So 2x over 2x is actually 1. So if you're taking out that whole piece, there should be a 1 there. Okay? Rolly, you okay? He's a very old dog. He's 14 and this humidity is killing him. We did some multiplying a polynomial by a monomial. You should be able to do that, I think. And dividing polynomials by monomials. The thing I really want to talk about is FOIL. First, outsides, insides, last. So I don't care what I give you. If I give you 3x minus 2 and x plus 5, in order to multiply a binomial times a binomial, we use the acronym FOIL. And F stood for first. Multiply the first thing with this bracket with the first thing in this bracket, which gives me 3x squared. O stood for outside. The thing on the edge of this bracket, the outside edge, with the thing on the outside edge, the furthest out on this one, which would be plus 15x. I stood for inside. The thing closest to the middle in this bracket with the thing closest to the middle in this bracket, which would be negative 2x. And L stands for last. The last thing in this bracket with the last thing in this bracket. Pay attention to your signs. Negative 2 times positive 5 is negative 10. At this point, the only thing you can do is simplify the like terms. So 3x squared and 15x take away 2x would be 13x minus 10. Very often, when you multiply a binomial times a binomial, you get a trinomial as an answer. So the acronym that is used most often for that is FOIL. However, I've had kids say it looks like a lobster claw or a clam or something by the way they draw the arrows. It looks like, you know, I don't care what you call it. Again, we talked about, and I know at least one person like this, we talked about doing it as a box. And so if you had 3x minus 2, so I've got 3x minus 2, this box for here and this box for here, and x plus 5, then you just multiply 3x and x, which would make 3x squared. You'd multiply 3x with 5, which would make 15x, you'd multiply -2 with x, which would give me -2x, and -2 with +5, which would give me -10, and then 3x squared, and then I can combine these two because they're like terms. 15x take away 2x is 13x, and -10. Some people like the box thing. I'm fine with it. I just find it takes up a lot of space and a lot of time. This is sort of for when you're just starting out and you need to get the pattern in your head. But foil, first, outsides, insides, last, or the lobster claw, tends to be faster for most people. So I said most often a binomial times a binomial will give you a trinomial, but we did talk about there's one situation where it doesn't, and that's in something called a difference of squares. If you have two brackets that are exactly the same except one has a positive and one has a negative, that is what's called a difference of squares. And what always happens when you do FOIL, x squared, outsides minus 3x, insides plus 3x, and lasts minus 9, negative 3x plus 3x is actually nothing. And so I end up with x squared minus 9. So I actually end up with a binomial. But it's still something called a quadratic because there's an x squared on it, but you don't have to worry about that yet. So whenever you have a difference of squares, the brackets are exactly the same except one's positive and one's negative. Those outsides and insides pieces, right, because this is firsts, outsides, insides, last, they will end up canceling out. So my little shortcut, and this is just me, like no other teacher is going to say this, is to do just FL. Just do firsts. X times x is x squared. Positive 3 times negative 3 is negative 9. Just do FLA, because your outsides and your insides are going to cancel out anyway if it's a difference of squares. The big thing to me in this section is the reverse of FOIL, which is factoring a trinomial. So if you have x squared minus 15x minus 16, and I said I want you to factor that. Now remember, some things are not factorable. Remember that the word factor means break it apart into its pieces. So in the one that we did right up front, we had, oh, I think I made it up. I can't remember what I had there now, but I had like 3x minus 2 and x plus 5. I had something like that, right? That's factored form. Here's a piece, here's a piece, and we put it together to be one trinomial. This is going in the opposite direction. I have the one trinomial. I want to break it apart into its pieces. And the pieces need to be set up in such a way so that if I do FOIL with the pieces, I end up with that trinomial. And there were some tips and tricks that I gave you. First off, what multiplies together to give me x squared? And we said that's easy, that's x. And I said then you need to make a decision about the signs. And to do that, first look at the last sign. If it's negative, then one bracket is a plus and one bracket is a minus, and it doesn't matter which one you put it in, okay? If this was a plus, then either you'd have a plus and a plus here or a minus and a minus here. If this was a plus and that was a minus, the plus would tell me the signs are the same. The minus would tell me I'm going to put a negative here and a negative here. But in this case, there's a minus here. So that means one bracket is plus and one bracket is negative. Now what I need is I need two numbers that multiply to give me negative 16, and they add together to give me negative 15. Because remember, with FOIL, I end up adding my outsides and my insides together when I simplify. So that's why it has to add to give me the 15x. So, two things that multiply together to give me 16. Well, 8 times 2. But 8 and 2 in no way add to give me 15. All right? 4 and 4 multiply to give me 16. But there's no way that I can have 4 and 4 and add them together to get a 15. And so a lot of people will go, well, I'm stuck. This isn't factorable then, because only 8 times 2 or 4 times 4 makes 16, because a lot of people forget 1 times 16. And you say, but 1 plus 16 makes 17, not 15. But remember your signs. If I need a negative 16, if I need a negative 15, sorry, if I make negative 16 and plus 1, remember they add to give me negative 16 plus 1 makes negative 15. And some people say, well, why is there an x on it? Think about it. If we were to do FOIL with this, okay, my firsts would be x squared. My outsides would be negative 16x because it gets multiplied with this. My insides would be plus 1x because the 1 gets multiplied with the x. And then 1 times negative 16 would be negative 16. Now when I simplify, negative 16 plus 1 is negative 15x minus 16. It should always work that when you do FOIL with the two brackets you come up with, you end up with the thing that you started with. Now, some may not be factorable. You may not be able to break it apart into pieces. I am very clear about when that could happen. If the instructions just say factor, it means you can factor in some way. You can break it apart in some way. But if it says factor, if the directions say factor if possible, it means some of them might not be possible. And so your answer is actually not possible. You can't do it. It doesn't work. So some of them are possible, but only possible a little bit. So I'm just going to watch this will work or something. Minus 8x plus 24. All right? If you have a number in front of the x squared, at this point in your math life, this will change. But at this point in your math life, that 2, I can likely divide all of my pieces by that number, and I can. So I can take a 2 out as a common factor, okay? I just divide everything by 2, so it's out here. So this is actually already at least partially factored. If you break it apart at all, it's at least partially factored. It might not be completely factored, but it's at least partially factored. So if it says factor, and all you can do is take a common factor of 2 out, that's possible. You have factored it. You're good. The only question you need to ask yourself now is, could this break apart and factor even more? If it cannot, then you're done. This is factored. If it can, let's see. Like I said, I just made this up in my head. Watch, it'll work. So this tells me my signs are the same. This tells me they're both negative. So I need two numbers that when I multiply them together, they make 12. And when I add them together, they make negative 8. So for me, the first thing I think of for 12 is 4 times 3. But 4 plus 3 does not make 8. So that's not it. The other thing that I think of with 12 is 6 and 2. And it just so happens that -6 minus 2 does in fact make -8. So this is fully factored. This is only partially factored. But what if instead of 24, the number here had been 26? Well, then this would have been 13. So I took the 2 out. So it's, again, at least partially factored. But there are no numbers that multiply to give me 13 and add to give me 8. So this is as factored as it gets. It is factored. It's broken apart. It just doesn't break apart very much, but it is factored. And that tends to be something that people don't understand. If all they can do is take a 2 out, they tell me it's not possible, but it is. You took a 2 out. That's factoring it. So that's basically what's in chapter 5. The only other thing would be section 5.11, where it's adding and subtracting fractions with letters in it. If you find you're struggling with that, please let me know and I'll make a video on that. But I wanted to go over this to answer any questions and to just kind of do some examples for you, kind of jog your memory on that. If you need this video, feel free to watch it. If you don't, then you didn't have to watch this and you didn't need to waste your time. But anyway, just in case you need it, there is some explanation for you. I hope it helps. Bye.